Hello and welcome to our lesson on recurring numbers. In this lesson, we'll build on your existing knowledge of decimals and fractions by introducing the concept of recurring numbers. We'll start by defining what a recurring number is and how it differs from a terminating decimal. Then we'll look at some examples of recurring numbers and how to recognize them. Finally, we'll apply this new knowledge by converting recurring decimals to fractions, reinforcing our understanding through practical exercises. Understanding recurring decimals is crucial, as it allows us to express infinitely repeating decimal sequence in a more manageable and precise form. So without further ado, let's get started. First, we'll explore what recurring numbers are and how they are different from terminating decimals. A recurring number, or repeating decimal, is a decimal number where a digit or a group of digits repeats infinitely. This means that if you could write the decimal out completely, it would never end, and the same digits would keep appearing in the same order. For example, 0.333, where the digit 3 repeats forever, or 0.777, where 7 repeats forever, are recurring decimals. We can also have multiple digits repeating in a recurring decimal, like in 0.121212, where 1 and 2 repeat forever. To make it easier to work with these infinite decimals, we use a special notation. We place a dot above the digits that repeat. For a sequence of digits repeating, we place dots above the first and last digits of the repeating sequence. Using this notation helps us communicate these infinitely repeating sequences in a precise and concise manner. On the other hand, a terminating decimal is a decimal that has a finite number of digits after the decimal point. For example, 0.5, 2.75, or 3.142 are all terminating decimals. Often, recurring decimals originate from fractions. For example, when we divide 1 by 3, we get 0.3 recurring, and when we divide 1 by 7, we get 0.142857 recurring. Recognizing and converting these recurring decimals into fractions is an important skill and something we will practice in future exercises. To convert a recurring decimal to a fraction, we will follow a step-by-step process. First, let's assign a variable, x, to the recurring decimal. For example, let's start with the recurring decimal 0.333. Our goal is to find the value of x as a fraction. Next, we multiply our equation by a factor of 10 or another power of 10, such that the recurring part of the decimals aligns into the same decimal place. Here we multiply by 10. Now we subtract equation 1 from equation 2 to eliminate the recurring decimal part. Simplifying the left-hand side and the right-hand side, we get 9x equals 3. Now we can solve for x by dividing both sides by the coefficient of x. Simplify the fraction to get the final result, which is x equals 1/3. With a clear definition and the notation for recurring numbers now understood, we are ready to try some more examples. Let's consider 0.45 recurring, which means 0.4554, 545, and so on. Let y equal 0.45 recurring. Now multiply both sides by 100 to shift the decimal point 2 places to the right. This leaves us with 100y equals 45.45 recurring. Next, subtract the original value of y from this equation. This leaves us with 100y minus y equals 45.45 recurring minus 0.45 recurring. Simplifying, we get 99y equals 45. We can now solve for y, which gives us the fraction 45 over 99. This simplified is 5 over 11. So 0.45 recurring is 5 over 11. Let's look at a recurring decimal with a non-repeating part. Consider 0.16 recurring. Let z equal 0.16 recurring. Multiply both sides by 10 to shift the decimal point 1 place to the right, giving us 10z equals 1.6 recurring. Multiply both sides by 10 again to shift the decimal point another place to the right, leaving us with 100z equals 16.6 recurring. Now, subtract the first equation from the second equation. 100z minus 10z equals 16.6 minus 1.6. Simplifying, we get 90z equals 15. Now we can solve for z. z equals 15 over 90, which simplifies to 1 over 6. So 0.16 recurring equals 1 over 6. Now let's convert 0.81 recurring to a fraction. First, define the recurring decimal as a variable. Let w equal sign 0.81 recurring. Now multiply by a power of 10 to match the repeating length. Since the repeating part, 81 inches, has 2 digits, multiply both sides by 100. Next, subtract the original equation from this new equation, leaving us with 99, w equals 81. Now we can solve for w by dividing both sides by 99. Simplify the fraction by dividing both numerator and denominator by their greatest common divisor, which in this case is 9. This leaves us with 9 over 11. Make sure to keep practicing this technique and using the notation until you feel confident. In today's lesson, we began by defining recurring numbers as decimals with digits or sequences of digits that repeat infinitely, differentiating them from terminating decimals, which have a finite number of digits. We examined examples of recurring numbers and introduced the notation for representing them concisely, using a dot or a line over the repeating digits. We discussed the practical use of this notation to handle infinite decimal expansions more easily. Additionally, we highlighted the relationship between recurring decimals and fractions, noting that recurring decimals often originate from fractions. We also went through converting recurring decimals to fractions, solidifying what we learned by going through example problems. By understanding and identifying recurring decimals, we can express infinitely repeating sequences in a manageable form. This knowledge not only enhances our number sense, but also equips us with the tools to tackle more advanced mathematical concepts. Watch the rest of the GCSE Maths course at Sophos Education.